people talk to each other or having people communicate with information automatically, right? And so what cloud communications in its modern incarnation is all about enabling web developers, people who are building web applications and using web languages, to now program phones and program the phone network. Because this is where all the interesting development is going on today. It's all in the web. And this is where we've done a lot of work to build out, scaling and reliability and languages and access to databases, etc. And so with cloud communications, you can now use all of these languages to programmatically control the phone network, right? But you don't just get using these familiar languages, you also get using the familiar tools. So you can now host your voice applications, not in some obscure telecom concept, but really in things like App Engine and Heroku and Microsoft Azure and even simple applications on Dropbox, right? Because these are all web addressable things. They can now be used to build voice applications. So the dividing line here is you got cloud communications up top, right? And this is where all the hard stuff happens. It's sort of real-time, high bandwidth, latency, sensitive applications, DSP, all these hard problems, right? And then what cloud communications does is bridge all of that and send metadata to the web application. So you don't have to deal with all these packets flying everywhere with voice over IP. All you do is think about metadata. What am I trying to do and what's happening on the call? And that's what gets sent to the web app over things like plain old HTTP and the regular old request response model, right? So we take this hard stuff and we make it easy. And that's what cloud communication is all about. It's not opening the world of telecommunications to a broad set of developers, right? So now what's really interesting, if you think about, okay, it's just plain old HTTP, for example, coming into a web app built on any popular language, right? It's your own environment, right? So you have access to all of the tools that you use to build web apps, all of your databases, your CRM systems, your business logic, mashups, all of the things that you're doing on the web can now be brought into the world of communications. Right? So how do we bridge the world of telecom and the world of these web concepts? You got these telecom concepts over here, you got web concepts over here. So what do we do to bridge it? So what we're doing is reusing successful web architectural patterns and bringing them to the world of voice communications. And so what does that mean? Well, two main things. First, we like things like RESTful APIs. Web developers get that, right? And so we're going to reuse that pattern. Another one is webhooks. That's another pattern web developers get and are very useful in the world of web development and web integration. So we're going to reuse that, and I'll go into a little more detail. So first of all, the RESTful API is great, because there's familiar tools that all developers know how to use to build against RESTful APIs. Things like web browsers, curl, Leah Culvert's Hurlit, HTTP libraries for every language, right? There's all sorts of tools out there. It's very easy to build against REST APIs. And so the challenge is representing these telecom domain objects in a RESTful form, right? So some of these domain objects are things like phone calls, or phone numbers, or SMS messages, or audio recordings, right? So now we build a way for you to be able to address these telecom concepts as a RESTful web service, just like any other RESTful web service, right? So a great example is in our API, right? If you do a get to a calls resource on the API, it returns a list of calls. It's a call log. Right? In the world of telecom, right, call logs are all done in proprietary formats. There's all sorts of weird ways to access them. You have to do binary translations, all these weird stuff. Everything's very vendor. Well, this is very simple. It's just RESTful, right? And it follows all the rules of REST. But then there's another part, which is, say you got that same resource calls. Well, the RESTful way is if you were to post to that calls resource, you would create a new call. And that's the RESTful way to create a resource is to post to a parent resource. Well, if you post to the calls resource, you create a new call, and you tell it who to call and what the caller ID is and all this stuff, right? And a new phone call is initiated. So via a RESTful web call, you've now reached out in the real world via telecom and actually initiated a new outbound phone call. So now the other side is webhooks, right? So webhooks is, and I'll give you a brief background on webhooks, but I guess everybody here is not at Jeff Lindsay's webhooks talk that's going on right now, so I'll give you the background. So webhooks are HTTP push notifications, right? It's an efficient way of communicating state changes in one system to another system that's interested in those state changes, right? So a couple examples, PayPal is one of the first great examples where when a credit card transaction went through, on the back end, they would push that state change, credit card transaction successful or declined or whatever, push that to your back end server so you could update your logic and start providing a service to a customer, for example. Another neat example is GitHub. So GitHub has this concept that you've got these post-commit hooks. So when you check in code, you can give the URL and say, hey, when the code check-in occurs, ping this URL and let my application know about it, right? And so these are webhooks right here. And that's exactly what's happening. State change occurs on GitHub, you notify my app so that I can actually take some action based on it. And it's much more efficient than, say, polling and things like that, which applications typically did before webhooks. And there's all sorts of familiar tools to building webhook-driven applications, right? Again, you can test them in your web browser. Postbin.org is a neat tool where you can actually capture traffic that's coming from a webhook to help debug. You know, you've got familiar tools like load balancers to scale out these applications, etc. And so in the world of telephony, what this means is you've got a phone, right, and you initiate a phone call. Well, a phone call itself is state, right? So that call goes into the cloud communications platform. And essentially, any state changes that happen on that phone call get communicated via webhooks to the web application that is controlling the phone call, right? So what are some of these state changes that happen in a phone call? Well, you know, a call begins, that's a new state. Some digits get pressed on the keypad, or a recording is completed, or a conference call begins, or a call ends, right? These are all state changes. And so they trigger that HTTP request out to the web app to say, hey, for example, a new call is beginning. Oh, and here are all the parameters. Here's who's calling. Here's who they called. Here's the city, state, and zip they're calling from. All this data to help the application make a decision about what should happen next.